Alright, hi. Today's reading is report number FRA-ORD 7822. Brake System Design Optimization Volume 2 Supplemental Data. April 1981 Final Report. Document is available to the public through National Technical Information Services, Springfield, Virginia, 2216-1. Prepared for the U.S. Department of Transportation, Federal Railroad Administration, Office of Research and Development, Washington, D.C., 20590. This document is disseminated under the sponsorship of the U.S. Department of Defense and Transportation. The Insurance and Information Exchange, U.S. government assumes no liability for the contents and use thereof. Notice the U.S. government does not endorse products manufactured, trade, manufacturer's names appear herely, and it's only because they were considered essential to the objectives of this report. And that gives you report number FRA-ORD 7820. The title is the Brake System Design Optimization Volume 2 Supplemental Data. Preface. The work described in this report was carried out under the direction of the Transportation Center of the U.S. Department of Transportation and with the context of overall project with the Federal Railroad Administration to provide a technical base for the improvement of the rail transportation service efficiency, productivity, and safety. The work was sponsored by the FRA Office of the Research and Development, Office of the Freight System. The final work is organized in 2 volumes. Volume 1 describes the work performed, present for the result of the study, and complete report. Volume 2 contains the supporting materials developed in the course of the study and which added substantially with the information but are no essential to the objective of the study. Currently, gradually acknowledged with the cooperation of many of the Railroad Rapid Transit Company, the Manufacturer Research and Development Organization, AAR, Brake Equipment Committee, with the members of the staff and the other interested parties who provided the information required to conduct a professional, original, objective study. We would also like to thank DOT personnel in the Transportation System Center and the FRA for their cooperation systems throughout the course of the study. And then it shows the metric conversion chart. Alright, 1 would be your introduction. 2 is going to be a functional performance of the brake system component subsystems. And that includes the brake air house, coupling, angle, cock, brake pipe, fittings, brake valves, air reserves, brake cylinder release valve, retaining valve, braking, rigging, handbrake, slack adjuster, brake shoes. And then we move on to 3, operation performance and design of freight car air brake system, introduction, operation performance, problems. Chapter 4 would be railroad private car, open survey, introduction, data requested railroad survey, data requested for the private car owners, result of the survey, thermal capacity of the freight car wheels. Chapter 5, and then it would begin the introduction parameters considered in summary, glossary of terms in Appendix A, and glossary B, references bibliography. List of figures, arrangement, brake system component, typical freight car, air hose coupling, typical angle cock, air hose location for the car is more than 5.5 by 6 inch overhang, pipe arrangement, typical freight car, pipe brake pitting, approximate brake pipe gradient versus temperature, typically a 100 car train, approximate brake pipe leakage versus temperature, typical 100 car train. Your AB control valve, quick release brake, cylinder release valve, exterior view, air brake control valve, exterior view, A1 reduction relay valve, the ABDW brake control valve, performance comparison, ABD, the ABDW brake valves, Z1A brake valve control, functional performance of the Z1A brake control valve during full reserve and service and application release. And then it continues, and we'll start our reading. All right. Alright, executive summary of this report represents the supplemental data of the support of Volume 1 survey and assessment. First, detailed description of functional performance of each of the freight car air brake system components is provided, but this is followed with a discussion of operation performance, design of air brake system, the result of the survey made with the estimate of the population of the brake system component of the survey, the present of the operation problems in which these components is presented, in addition with the problems with require immediate solution with the perspective of the railroad industry tabulated. Finally, a summary recent research work performed in investigating freight car wheel thermal capacity is presented. Alright, 1. Introduction. The volume reference for the supplementary data of the information which support the material of the presented with the volume 1A survey and assessment of the volume is included with the 4 section valve with the 2 appendices of the components with the section which valve, section 2 functional performance of the brake system components, Subsystem. This section presented with a detailed description of the functional performance of the freight car brake system components. Section 3, Operation Performance of the design of the freight car air braking system. Section describe how various brake system components interact, and it is the system delineates operating problems presently associated with each. Section 4, Railroad Private Car Owner Survey. Section prevents the survey results of the railroad private car owner. With the results include rail system operating condition of the air brake system, operating problems, air brake component populations, equipment being purchased, and then special brake system equipment in service. Section 5, the thermal capacity of the freight car wheels. The section summarizes recent research of investigated freight car wheel thermal capacity limitations. Here, 2 appendix include glossary of terms and reference of bibliography. Section 2, Functional Performance of the Brake System Components and Subsystem. Functional performance characteristics of the selected brake system components of the subsystem presently in use are presented in the section in following order. Brake air hose couplings, angle cocks, brake pipes, fittings, brake control valves, air reserve, brake cylinder release valve, retaining valve, brake rigging, handbrake, slack adjuster, brake shoes. Each of the above brake system components and subsystems is discussed in terms of the need of the development of the performance, any problems associated with their use. Figure 2.1 presented with the following page for the aid to illustrate location components of the typical car to indicate the function and interaction with the components with respect to a freight car brake system. And that shows you have your brake pipe, retainer, your ABD valve, the release rod, combined auxiliary emergency reservoir, auxiliary lever, brake cylinder, slack adjuster, cylinder lever, top rod, top lever connection, bell crank, brake shoe, hose and coupling, angle cock, handbrake, and truck lever. Figure 2 was an arrangement of brake system component for the typical freight car stored for the Air Brake Association 1972, used by permission of the copyright owner. 2.1 Brake air hose coupling. With the air hose coupling, glad hands provide with a flexible brake pipe connection between the car's end train. As shown following page of the figure 2.2 of the air hose, this part subassembly includes the hose coupling, 2 clamps, and the pipe nipple that attach to the brake pipe over the car. Also, note that the nipple and the marking over the top of the nipple must be when used. The coupling and identification label is shown. Then show the coupling of the glad hand and the note 1. The figure 2.2 was the air hose coupling. Source Association American Railroads 1978 B page E51 1978 U with the permission of the copyright owner. The air hose with the coupling glad hand with incorporated with the rubber gaskets to form a seal are connected manually, raising the 2 air hoses with the proper angle and lowering them in such a manner that allow the coupling to rotate relative to each other, causing the flange of the coupling to engage. Air hose uncoupling performed automatically when the 2 cars are being mechanical uncoupling process. Tension and force produces the air in the hose after the cars separate, cover the coupling to move vertically upward and rotate so that their flanges become disengaged and permitting them to separate. There are presently 2 AAR specification air hoses, namely specification M60171 AAR standard, specification M60153 AAR alternative standards. Our type of the air hose having them tested for the recent year with the primary emphasis with improving the air hose life with this include with the air hose with the braid with the shield with the wear enforcement and with the material such as neprine. The primary disadvantage of the using alternative material has been extreme with the hose with the rigidity encountered during cold weather operation, which makes it difficult and impossible for one man manually to bend with the hose to the coupling position. According with the AAR Interchange Rule 5, where limited gauging care for the renewal of the air hose as follows. Association Railroad 1975 Rule 5. A burst leakage is discernible with soap and sud test, abrasion, cracks, and soft spots, etc. Loose defective fittings, either the end or end of hose 3/8 inch more of shoulder and either nipple coupling. Porous has determined the soap and stud test spliced over 8 years old, determined with the date of the hose, date obliterated time of the COTS and IDTS of the air brake missing. Sure for the proper function for the air hose glad hand with the hose assembly must be properly mounted with the line with the car with the proper air hose mounted with alignment may become difficult to assure under all operating conditions, especially with the long freight cars having long overhanging couplers or supported by shock absorbing cushion devices that have long travel distance. Although specification air hose and some of the insulation arrangements specified by the AAR 1975B with the air hose separation problems are one of the most frequently cited with the deficiency present with the air brake system in the railroad data survey performed with the current project. 12 out of the 17 railroad included air hose coupling in the end of the car arrangement as one of the areas that should be given the highest priority. Table 4-5 in the improving the freight train braking system. Alright, 2-2, angle cock. As shown in figure 2-1, the angle cock is normally attached to the end of the brake pipe at each of the end of the car. The purpose of the angle cock is to provide a manual positive airflow cut off of the brake pipe. The angle cock is typically used when a portion of the train is moved separately during the picking up and setting out over the block of the cars from a road train. For example, if the block of the cars is to be set out of the head end of the trainman would manually close the angle clock on the rear of the last car over the head end block to be set out. Upon uncoupling the train at this end point, the air hose would separate, throwing the rear unintended portion of the train into an emergency to prevent it from moving. This would occur because the angle cock on the front end of the front car would be left in its open position. The front of the portion of the train could then be moved with the air brakes charged properly functioning. Alright, angle cock located specification provided with the AR specification number 5218 in section E of the manual standard of the recommended practice. Figure 2-3 show the specification angle cock air hose location cars overhang greater than 5 feet 6 inches from the truck center end of the car. Alright, this shows your hooks as shown for figure E3. Here's your coupler. There's your note 2, note 1. Train line pipe, center of the car, floating ball, floating sill, stationary bracket, floating sill, swivel type hanger, AAR approved flexible hose, AAR standard 22 length hose, 4 foot minimum, 4 and 5 inch minimum, note 2, top of the rail minimum maximum, fixed sills, floating sill. And that shows the typical angle cock air hose location for cars more than the 5 foot 6 inch overhang. Association of American Railroads 1978 BEP E32A 1976 U for the permission of the copywriter. Suitable angle cock location difficulties specify a long car with certain coupler cushioning devices in addition with the air hose separation problem discussed previously. Both angle cocks and air hose can be damaged and bypassed by coupler impact switching classification operations. Alright, 2-3, brake pipe and fitting. For the brake pipe likely is 1, shown figure 2-1, instructed with 1 1/4 inch extra heavy pipe with a 1 1/4 inch diameter will be selected with optimum diameter and satisfy both of the airflow volume requirements for the brake pipe and a long train. Shown figure 2-4, typical freight car includes the other pipes in addition to the 1 1/4 inch brake pipe. The size minimum bend radii with all the brake system components pipes specified by the AR manual standard recommended practices. Figure 2-4 shows the piping arrangement. Typical show you will blow this up to 100, and it's still a little bit hard to read, I guess. But anyway, here's your brake valves views, brake cylinder, and it shows brake pipe, and then glad hand over here, T joint. Alright, Air Brake Association 1972 permission for copyright owner. That was the brake piping arrangement of the typical freight car pipe installation skirmish specification publicly AR specification number 2518. One of the primary functional performance aspects of the brake pipe with the mount of the air brake system, the leakage present with the connection fittings on the various brake pipe with the top of the air brake system, leakage with the rest of the paper with the Palmer 1975 with the paper dealt with the various air brake system leakage improvements made over the past 50 years, defining the following with the two sources of leakage, brake pipe leakage for the brake pipe, hose assembly, angle cock brake pipe with the charging ports for the AB type typical and type control valve. System leakage with valve of the release for the position fully charged. All leakage leaks for the brake pipe. Leakage for the reservoir control valve. Leakage, although the leakage test performed in the past 50 years verified conservatively in the test, best of the criteria for the result show for the total brake system leaking the decrease over the period of time. Table 2, 1 compressed with the pairs the leak test of the result of the test made over 50 years. Table 2 shows the comparison brake pipes leakage test over the period of 50 years. You have 1925, 1950, 1975, 1925, 1950, and 1975. Based on the percent of the car tested that had leaks, based on total leaks, based on total cars. And then you show the source and hose leakage, angle cocks, brake pipe, branch pipe, brake valve, reservoir, base number of percent. The result of the table 2 would be with the different test with the perceived with the criteria illustrated with the air brake system leaking with the decrease over the period. For example, 1925 at 87.4% of the cars checked that had brake pipe leakage. In 1950, only 9.8% of the cars had checked brake pipe leakage. Furthermore, than 1955, only 1.1% of the brake percent of the cars checked as audible brake pipe leakage. Most recent test valve of the present with the palm over the dealt with the effect of the cold weather on hand brakes leak on brake system leakage. Although the test involved with a small sample of the observation could result with the indicated cold weather adversely affects leakage. Temperature for that is less effective with the brake pipe leakage. The system leakage of the average car elevated with the consumed 0.42 cubic feet of free air each minute. A poll of the railroad repair facilities indicated that 40% of all the cars tested with too much leakage with the pad. With the single car test when originally tested, this tends to say that in its past 25 years, leakage levels have not been changed appreciably. Proceeding with the test were performed with a sample of the air brake system leakage rates for the number of the typical cars in acceptable operating condition. The result of these tests was interrupted by conservation and historical development of the brake pipe fitting for the present requirements prior to the 1950s. The brake system and the leakage commonly resolved with a fracture of the threaded area over the brake pipe fitting. Earlier in the 1950s, these fittings were introduced employing with the rubber compression grips. However, the leakage of the problem persisted during cold weather due to the insufficient high tightening of the glad nuts with the compression fitting. For this led with the introduction of welded fittings. Presenting AAR rules require the replacement of the compression fittings with welded fittings of the car shop from 150 or more man hours of work. Compression fittings and the welded fittings are illustrated in Figure 2.5. Alright, compressor fitting on the top of the compressor ring, the pipe LOC leak ring, or pipe LOCK ring body, flange ring, welded fitting, brake pipe fitting, Figure 2.5 show the brake pipe fitting. Also related to functional performance of the brake pipe with the fittings, even the width of the fittings over the repair with the failure of the pipe was problem with the discuss of the Berlin Angel from 1971 respect with the special problem associated with the repair leak of the cars with the cushioning under frame with its valves. Illustration of the brake pipe with the cushioning under frame with the cars between the sliding with the stationary center shovel made up with locating with the repairing leak for the damaged pipe with the very difficult without dissembling with the underframe with a more distinct line. Attention is needed in this area. The author continues, except for the brake light leakage is one of the major contributors to the poor train handling. With this defect can be due to leak with the pipe to cover improperly anchored for the train line with the fitting of which allow the pipe to shift during with the coupling of slack and the action. Defective with the air hose with the gaskets and angle cock. Sometimes this type of the defect is not easily detected during the terminal test. During train movement of the stretching out of the train with the leak for the more of the halves of the occur with the train line. This is not adequately with the anchored car with the compression fittings which seem to have them more vulnerable to become the real problem with the brake pipe attached to the sliding shovel with the cushion car. But unfortunately, in many instances, they alleged with the practice with the torch cutting and access to the holes and stationary center shelves in order to tighten hiding fittings. In addition, with effective overall train braking performance of leakage have a direct impact with the freight train operation. The rules governing the operation of a freight train with required with the air brake leak will be less than 5 psi per minute. Brake pipe pressure gradient with by less than 15 psi. If the common practice limited with the train length with the cold weather the operation in order to meet legal minimum leakage requirements as shown in Figure 2.6 for the following page. Minimum brake pipe gradient 15 psi is difficult to achieve with over a 100 car train operated with the ambient temperature below 0 degrees Fahrenheit. And then show the gradient in psi versus the temperature degrees in Fahrenheit. That's 10 degrees increments and approximate brake pipe gradient versus the temperature for the typical 100 car train. Palmer 1975, curve 1, use of the permission of copyright owner, comparison curve shown with the brake pipe leakage versus ambient temperature shown, figure 2.7 of the following page. Show the typical approximate type brake pipe leakage versus the temperature for the typical 100 car train, temperature, degrees Fahrenheit, brake pipe leakage PSI, and a minimum. Palmer 1975, use of the permission for the copyright owner, shown for figure 2.7 of the minimum brake pipe, minimum leakage requirement of 5 psi per minute, the difficulty to achieve with a 100 car train with the ambient temperature drop below the freezing point, while both curves shown figure 2.7 and 2.7 the approximate, they do not illustrate the leakage limit, but the more restricted than the brake pipe gradient limit. This result of the head portionally resolvable with the request for the validity of 5 psi minimum leakage rate limitation re-examined. You for the gradient instead of the brake pipe leakage as the only criterion ensure for the operable train brakes were discussed in the paper of the Blaine and Hangel of the 1971 paper practical for the limit of the satisfactory brake control was assessed for the airflow damage demand under 60 cubic feet a minute, probably 60 cubic feet a minute or less, by establishing a relationship with the brake pipe gradient with the leakage for the authors include, but to keep the airflow rate with the 50, 60 cubic feet a minute, with less of the gradient with the must be held with the 5 psi with the 50 cars, 10 psi with the 100 car, 15 psi for the 150 car with the effect of the air leakage with the brake pipe with this airflow with the corresponding with the brake pipe leakage, 20 psi minimum a minute for the 50 cars, 12 psi a minute with the 100 cars, 8 psi a minute for 150 cars. However, the 8 and 10 psi minute with the brake pipe leakage or stopping distances become adversely effective. The effects of the brake system leakage of the train bike performance is discussed with the part C of this section. 2.4 brake valve. The function performance specification for the brake valve that are contained with the AAR's manual standard recommended practice. The specification pertaining to the operational response of the brake valve with respect to its relationship with the other valve of the component of the air brake system of the freight train. The functional performance character of the brake valve that you today described in the terms AB and ABD type of the brake valve, with the addition with the more advanced brake valve with the present under evaluation include with the ABW and the Z1A with the primary function with the performance aspect of each of the valves are discussed in the following paragraphs. 2.4.1 AB brake control valve. The AB valve is the oldest, most common of the control valve that today. Each of the function with the performance of the AB valve could be considered with the same with other brake valves compared. With the AB valve was introduced in 1930, replaced with the K valve. With the last K valve was removed with the interchange service in 1953, shown figure 2A with the primary performance feature of the AB valve will include with the better quick will serve with the function retarded recharge, releasing, ensuring more sensitive to the application than the K. In addition, the AB had a separated emergency portion allowing with a much faster emergency transmission speed over the 900 feet per second to control the slack action. During brake application, the AB provided with the initial fast and limited brake cylinder pressure to punch slack valve with a more gradual pressure build-up, given the full pressure within approximately 12 seconds. Show the figure 2H of the AB control valve with the quick release brake cylinder release valve with exterior view, figure 2A. Brake cylinder review, release valve position, reserve release position, service portion, pipe bracket, emergency portion. Source for the A brake association, you with the permission for the copyright with the A brake with the full emergency application for the 150 car train required approximately 17 seconds, whereas full service application would require 2 to 3 minutes for the development of the plane with the 1975B. The manual for the requirements of the COTS and the AB valve with the present with the base with period of 48 months. 242 for the ABD control valve with the 1950 for the operating of the long freight train with the need with the greater flexibility with the train braking operation become apparent. Desirable direct release features of the brakes of the difficult to achieve with the long train with especially leakage with the concentrated in the rear. Lift with the brake pipe pressure with the could be increased with the high rate with the high end of the train leakage with the rear and with the could cancel with the release signal. Increased brake pipe pressure with the and the brake relief within the train would not relieve with the prevent with the train with the be pulled apart during with the release with the moderate heavy brake application. Trains would be allowed with the top of the complete before releasing with the brakes. Recognize the need of the direct release capability while the train's in the motion. Brake control valve the designers develop and accelerate surface relief. The feature for the brake control valve. The feature also allows a small amount of the air for the emergency component of the air reserve the damage for the brake pipe locally overcome the leakage effects. Thus, accelerated release propagates through the train speeds of 450 to 600 feet per second. Accelerated release feature with the first demonstrated with the AC valve, later incorporated the ABD valve shown figure 2.9. Figure 2.9 for the AB control valve, the exterior view of the emergency proportion, combined release rod, release position, service portion, pipe bracket. So for the Air Brake Association, either the permission for the copyright ownership, the note of the facility, conversion of the AB valve of the ABD valve, the serve of the emergency portion of the ABD valve of the mount with the original brake pipe bracket, either the AB valve, see figure 2.8 and 2.9, by changing the decision material of the ABD valve of the COT with the maintenance of the period of the ABD valve, resulting extended from 8 to 10 years compared with the 4 year of the AB valve Association Macromeros 1975C. 243, the ABDW braking valve. Well, the ABDW design with ABD valve was designed to provide running release capability of producing faster, more effective brake pipe pressure increase. There was also a need to decrease the time and apply brakes of the train in order to reduce stop distance. To assist with making the brake application for the longer cars by having the brake pipe of the air valve with the device known as the A1 reduction relay valve, designed and applied. The A1 reduction relay valve, which illustrates figure 210, assists with the AB and ABD valve, making brake application both service and emergency valve. The A1 reduction relay valve has a quick service valve portion, pipe bracket, and valve vent portion. The Air Brake Association, you with the permission of the copyright owner. Brake pipe reduction with the surface rate with a quick surface portion of the A1 reduction relay valve locally vent with the brake pipe there through a choke with the surface rate through thus assisting with the propagating surface applications of the train for the brake pipe reduction emergency rate with the vent valve portion of the A1 reduction relay valve locally vent with the brake pipe air with the emergency rate. The requirements of the mandatory illustrate for the A1 reduction relay valve on all cars having more than 75 feet of the brake pipe with intent to prevent deterioration of the brake performance of the car with the increase of the percentage of the long cars. However, this feature with the desirable on use of all cars regardless of their length and respond to the need of the ABW brake valve was designed to integrate with a continuous quick service feature for the upgrade of the surface braking on all cars lower cost with the improved functional performance of over the A1 reduction relay valve. Right, 1975 ABDW valve was shown figure 211. The schematic of the internal passages of the ABDW is presented in section 3, figure 3.3. So this shows figure 211 show the ABDW brake control valve. Figure 212 show the manufacturer performance comparison between ABD and ABDW control valve, the full service brake applications. That is as shown in figure 212 with the 150 car train complete with equipped with the ABDW for the brake valve of the manufacturer with a particularly almost 50% of the improvement of the brake cylinder pressure build up time shown with the ABDW control valve has been demonstrated with the brake equipment committee with the AAR is presently under consideration accepting change with the interchange for the member of the road. Z1 brake valve control valve. Z1 brake valve control valve with another advanced brake control valve with the presently under consideration AAR approval of the interchange service. According to the manufacturer of the G1A with the valve with the design with the provide both reduce the initial cost of the maintenance with the cost to do, provide improvement of the performance of the reducing shift with the propagation of the time of the valve leakage. It also the design to for the full compatibility interchange with the ABD type of the brake valve presently in the use of the outline view with the Z1A brake control valve shown in figure 213. This show for the figure 213 show for the G1A brake control valve. According to the manufacturer, the G1A would have the launch potential of life with lower maintenance cost for them present with the brake valve, the cover, the use of the positive valve instead of a spool type valve attributed with the two main causal factors to restricted life with a spool valve with the one rubber seal with the rapidly applications such as spool valves will involve movement that seals over the ports of the bore. The high velocity air moving around the spool. Remove the lubrication critical for the long seal life of the functional performance during full surface application release the Z1A valve shown in figure 214. Alright, this shows the brake pipe front with the brake pipe rear, the Z1A control valve 70 to 100 foot cars, full surface application release, the event in 1 minimum 100 0 to 100 psi, brake cylinder front, brake cylinder rear. This shows the functional performance Z1 brake control valve during full surface application release, Westinghouse brake signal in 1975, air reserve. 2.5 air reserve. The purpose for the air reserve of the stroke of the compressor air for the air brake as braking energy during the brake release between the being limited with the brake cylinder or the brake control valve brake application air reservoir shown the 215 and two separate for the compartment, the auxiliary compartment that two stores air for the brake application, the emergency compartment with the stores air from the emergency brake application. Show figure 215 show the air reservoir of the train dynamics 1973 for the permission of the copyright owner. Volume auxiliary air reserve compartment of the system charge 70% PSI will reduce will produce a brake cylinder pressure approximately 50 psi following service application. Emergency compartment air reserve the volume of the typically 3,500 cubic inches, such with the equipment initially charged with the 70 psi of the brake reservoir valve with the brake cylinder pressure equalized with approximately 60 psi. Following emergency application of the standard 10-inch of the cylinder with the 8-inch piston travel the WAP code in 1917 to page 9. Table 2 show the full circuit of the emergency brake cylinder with the equalization pressure requirement of the differential valves of the initial brake pipe charge pressure. Figure table 2 full circuit of the emergency equalization pressure brake cylinder pressure with the verse of the initial charge of the brake pipe pressure. Show the initial charge brake pipe pressure and the equalizing brake cylinder pressure full circuit in emergency. You would have 70 and 50, 60, 75, 53, 64, 80, 57, 69, 85 initial brake pipe pressure charge, full service 65, 72 emergency. Brake pipe pressure, initial charge 90, 64 full service 77 emergency PSI, 171 full service 85 emergency, 110, 78 full service 93 emergency. And as shown in the table 2 with the emergency equalization brake cylinder pressure approximately 20% of the grade greater than the full service brake cylinder pressure regardless of the value of the initial brake pipe cylinder pressure, the result of the pressure volume relation with the emergency auxiliary air reservoir compartment and the brake cylinder. 2.6 the brake cylinder. The purpose of the brake cylinder and test for the provide of the braking force with the car applying with the brake shoe with the gimbal for the wheel with the during with the application with the brake cylinder with the exist with the two types. One type conventional indirect acting with brake rigging AB1 and ABU. The different type of the direction action with the truck mounted rigging. Figure 216 illustrates AB1 type of the brake cylinder with the U with the conventional brake rigging. Typical type 216 AB1 type of the brake cylinder with the U with the conventional brake rigging. Air into the brake cylinder through the port with the left of the display with the position compressing the return spring applying with the force of the brake rigging with the total brake cylinder of the valve. You must properly relate to the air reservoir volume produced with the required with the brake cylinder pressure for the proper produced braking force development by brake cylinder depending on the friction of the low friction brake shoe with the brake cylinder with the proper diameter the most selective with the design of the brake system. In addition with the brake system, freight car with the converter with the using a low friction with the high friction brake shoe with the installing pushing kit with the brake cylinder to reduce the effective piston diameter through the producing lower brake force of the brake cylinder with a bushing kit installed with the shown figure 217. 217 show with the brake cylinder bushing kit. 217, the brake cylinder release valve. The purpose of the brake cylinder release valve is to permit the manual bleeding of the air through the brake cylinder of the car after the brake pipe pressure has been completed in preparation for the switching of the classification of the brake cylinder relief valve, eliminating the need to bleed the air reservoir compartments there of the reduce the need of time and the need of the recharge of the reservoir during the outbound train preparation. One of the manufacturers of the brake cylinder release valve, they estimated that 40% of the time that can be saved with recharging a 150 car train with each of the car that have the valve installed. The brake cylinder release valve may be mounted properly with a pipe rack with the AB valve with the recent manufacturer installed with the older AB brake valve with an adapter kit with the ABD brake valve with incorporated with the brake cylinder release valve with the standard features shown figure 218. 218 show the brake cylinder release valve with the part ABD brake valve with the pipe bracket service portion emergency portion brake cylinder release valve. And that with the performance specification brake cylinder release valve that provided with the Association of American Railroads with 1875 B pages E385 and then E42. Manual actuation valve with the charge for the single voluntary pull with the release valve with the deplete with the brake cylinder pressure. Although the feature of the desirable, the car inspectors several yards routinely bleed both the brake cylinder and the air reservoir holding the release rod prevent the air in reservoir from leaking through the defective brake cylinder relief valve with the replying with the brakes. The problem was also described after the railroad survey result of the Part B, Section 4, Table 4, 3 through 411. 2.8 retaining valve. The purpose of the retaining valve is to maintain the minimum amount of the brake air pressure for the brake cylinder after the brake relief has been made with the car reservoir being recharged with the feature used for the service. Descending with the grade territory so that the train brakes are not inadvertently released. Retaining valve with each car must manually be both activation and release. Alright, prior to 1967, the retaining valve was incorporated with the four positions as shown with the direct EX, the direct result of no air restriction. EX HP that retains 20 psi of the brake cylinder train brake are released. EXLP retains 10% of the brake cylinder train pipe brakes at release. EXSD slow direct exhaust. Brake cylinder pressure is completely exhausted by at a slow rate. In 1967, the three-position retaining valve was introduced. Figure 219, three-position retaining valve was emitted with the exhaust low pressure position excludes the exhaust high pressure and the exhaust S position. Functional performance specification both type the retaining valve presented in the Association Merry-Go-Round Roller 1975B. Alright, figure 23929 show the four-position and the three-position retaining valve. The four-position and the three-position. And then prior to the introduction of the dynamic brake of the diesel electric motor, the motor with the retaining valve was used routinely for the operating heavy freight train with the steep descending grades. Today, however, the retaining valves are used only under certain circumstances, but typically in service of the grade with the dynamic brakings are not available, or coal mining tipples, NTR main lines, or on certain exemptional steep over 2% main line descending grades, section 4, table 4.2. 2.9 brake rigging. The purpose of the brake rigging is to multiply with the distribute the brake force of the develop of the brake cylinder tube of the brake shoe with it over the car. Cover the introduction of a different type of the length of the capacity for the brake car demands with the heaven plate design with the design of the air brake with the design rigging with a bolt produced adequate brake level that can be physically attached to the freight braking car without interfering with other devices and appliances. Brake rigging used today is in two types of indirect acting, conventional rigging, and direct acting, truck-mounted rigging. Functional and performance of both types of rigging, such as the AR net braking ratio specification. See section 3 adhere to. Conventional rigging, indirect acting, figure 220 to illustrate the typical configuration, conventional type of the brake rigging, and one several of the different brake rigging arrangements can be used depending on the configuration of the car and the other factors. Achieving the required net braking ratio for the design of the conventional brake rigging can cover the forces produced with the brake cylinder with the multiply selecting the proper level of the ratio. However, the total lever ratio must be limited to 2 with a not greater than 12.5 to 1. Double acting automatic slack adjuster usage of the preserve the volume relation between the air reservoir with the brake cylinder is not adversely with the effect of the brake shoe wherever the stress of the produced design level of the rods, jaws, pins not limited to the inherent design valve. The AR specification grub with a metal badge plate with a fastened underframe with each of the brake cars shown with the design brake lever to the dimension for the brake rigging. Example of the brake rigging badge plate shown in figure 2 of 21. With the net braking ratio with include with the loss of the efficiency of various brake rigging components. Section 3 with the estimates efficiency need of the design. So with the efficiency loss of compensate with the brake rigging force design calculation. Efficiency loss of the various brake system components have been estimated for the test. The result of the test to get efficiency, the various configurations of the brake rigging differ considerable over the approximate efficiency valves have been determined in table 2.3 on the page 32. Alright, your bottom rod through the bolster. Brake cylinder, left slack adjuster. I can't read these. This would be bottom rod underhang, top rod underhook and eye. 3 lever truck arrangement. I figure 220 show the 4 configuration conventional brake rigging. So for the Air Brake Association 1970, you for the permission copyright owner. This show for the brake badge patch shown in the for freight cars. Table 2.3 approximate values of the efficiency loss of the brake rigging. Brake cylinder 7.5 inch components 111% and brake cylinder 8 inch 10%, 8.5 inch 9, 10 inch 8, 12 inch 7 pins 1 per pin. Slack adjuster, pneumatic efficiency loss 5, horizontal pads 1, unit beams 1 per beam. Field testing has been produced approximately efficient for the range of the brake rigging of various type of the car with the new result of the shown with the conventional brake rigging efficiency can be ranged from minimum approximately 45% to minimum approximately 75%, and here an advantage of the certain arrangement of the conventional type of the brake rigging truck mounting introduced the reaction force of the brake rigging during the brake application. According to the manufacturer of the truck mounted with the type of the brake rig with the turning force of the reduced lateral force exerted with the flange of the wheels, again for the rail with the magnitude of the force on beat order with the 490 pound with the depending on the brake rigging configuration. Figure 222 illustrates for these force of the two configuration of conventional rigging. Alright, show the top rod over the bolster, dev lever, anchor over the truck bolster with these turning motion, friction movement, lateral force, bottom rod under bolster, dead lever, anchored car body, top rod force, anchor car body. Alright, interviews conducted with the freight car wheel manufactured private with the car line, releasing company with the large portion of the wheels removed with the flame with the wear with the produced of the two wheels of the truck, one each axle with the symmetrically wheel wear, as if they become with the described with the truck around turning with the become moments with the produced with the conventional brake rigging. A secondary problem in the area with the conventional type of the brake rigging with the uneven the brake shoe with the forces of the distribution produced with the various wheel of the car, producing a higher average brake shoe force with the wheel on the wheel with one wheel of the car compared to the other with the tending car with the wheel sliding when the car is empty with the thermal loading with the result of the wheels of the loaded. Conventional rigging can also be bottom out with the rigging with the not manually adjusted with the multiple wear wheels, or placed one wear wheel depending on the type of the rigging with the additional brake shoe with the travel required with the one wear wheels can cause rigging to come into contact with the truck bolster center shovel, making the brakes useless. Part 292, truck mounted braking, direct action, truck mounted with the type of the brake rig with the combined with the function with the brake cylinder with the brake rigging, the brake beam with the compartment of the truck with the mount arrangement, figure 223, illustrates truck mounted brake ring designed by Wabco rigging as the trade name Wabco PAC, similar rigging produced with the New York Air Brake Company as trade NYCO PAC. Illustrate a typical truck mounted brake rigging, one truck shown. As shown in figure 223, the truck mounted brake rigging requires 2 brake cylinders per truck, 4 cylinders per car. Because of the brake cylinder directly upon with the brake beams efficiently low, and here with the conventional type brake rigging are not present in the truck mounted with the brake rigging efficiently. Its typical range of the 80 to 10 knots, 90%. Other benefits associated with the truck mounted type of the brake rigging include with the absence of the truck mounted turning moments result of the brake application shown in figure 224 with the truck mounted brake rigging produced with the symmetrical application of the braking force. Figure 224 shows the force distribution truck mounted direct acting brake rigging. The more uniform force of the distribution produced with the truck mounted with the brake rigging show with the reduced with the tendency with the wheel with the sliding empty car with a high wheel. Thermal loads on an only wheel with the car with the potential brake shift with the design problem with the truck mounted with the brake rigging of even that is most efficient with the conventional rigging with effective lever ratio with only 2 to 1 compared with the level ratio 12.5 to 1 conventional brake rigging. In order to meet with the net braking ratio one with the high capacity of the car with the U with the truck mounted rigging with the high friction brake shoes are required U with the conjunction of large diameter brakes on the operated disadvantage associated with the truck mounted with the type of the brake rigging have included most costly COTS and expense with the main with the required with the 3 additional with the brake cylinders and damage with the brake cylinder with the coal hopper with the call with the exposure of the flame with the thaw sheddings. The sheds. The cylinder also frequently damaged with the car derailed with a more serious problem recently been corrected with the manufacturer has been with a hand brake arrangement with the truck mounted rigging and certainly hand brakes with the rigging applied with a brake shoe. Brakes only one end with the B end of the car with to provide adequate holding with the capacity of one truck with the brake force with a substantial greater than the produced of the truck with the equipped with the conventional brake ring with furthermore inspection of the various ground crews would often result in the incorrect interpretation of the release brake with the end of the car made with the hand with the brake of the car has been released, resulting in relatively high frequency unreleased hand brake with combined with the substantial higher end brake forces produced with a high incident with the B end of the wheel removed with the due to the slide spalling built-in tread correction that has been provided with a handbrake rigging that applied both trucks of the car Wabco 1975. Part 210 handbrake. The main purpose of the handbrake is to hold the car in stationary long period of the time, although the handbrakes are also used with a limited number of the operation control manually the speed of the cars during collision classification to reduce car impact force. The handbrake freight cars generally described in terms of physical application. These include vertical wheel assembly with a horizontal wheel, usually a drop shaft assembly with a lever type assembly. Figure 212, 25 illustrates typical vertical wheel brake and assembly. The handbrake is manually operated with the crew member rotating the wheel with which would wind the chain around with the sprocket. Sprocket is geared with the wheel with the restraint with the ratchet of the reduction gear with the resulting force with the transfer of the brake with the cylinder with the brake rigging through the combination of shoe wheel with the bell crank depending on the design of the car with the type of the brake rigging. With the handbrake may be released manually activating reach lever the upwinding of the wheel with depending upon the design. Unfortunately, releasing the handbrake is sometimes overlooked. The car is moving in the train within the yard with the handbrake applied with depending upon whether the car is empty or loaded. The wheels might slid or skip at the car with the flash valve with a high treaded temperature respect with the performance specification. The handbrakes published in the Association of American Railroads 1975B. Specification vary according to type of the brake ring with the brake shoes installed on the car. 211 slack adjuster. The purpose of the slack adjuster: remove the slack eventual brake rate with the tube with the brake shoe, otherwhere with the twist with the brakes on with the piston travel to maintain with the proper piston travel must be maintained so with the pressure with the volume relationship between the air reservoir with the brakes on with is not out of balance. Brake rigging lever ratio with the 8 to 1 with the shoe wear with 1/8 of an inch car with a 1-inch piston travel extended with the region with the FRA requires less than 9-inch piston travel at the initial terminal. The brake shoe condemning limit is specified. It should be noted that while the proper position piston travel is important, but the piston travel does not indicate with the total condition of the entire brake rigging. Prevention typical area that provide with the brake rigging lever to ride with the correct lever to angularity, interference with the manually relocating pin placement square up with the rigging. Figure 226 illustrated the operation one type of the automatic slack adjuster. And it shows the slack adjuster in the figure 226 the slack operator adjustment. Mechanical slack adjuster shown with the figure 226 with the exhibit enclosed with a long spiral with a worm to rotate with attached with the spring with the design with the short end with the automatically win with the brakes. Please do adjust the brake shoe wear with the wind more brake shoe with the replace with the new one with the unit with the automatically linked with the first brake applicator to provide proper piston travel slack adjust the group of the coin with the air point with the applicator for the brake rig with the air type of the operation mechanical and pneumatical shown in figure 227. The performance specification certification procedure with the automatic slack adjuster published in the Association of American Railroads. And then show the different the typical AR application automatic slack adjusters. 212 brake shoe. The number of the different type of the brake shoe with the present with the freight strip with the different primary with the material with the construction with the alter with friction wear with the sparking character with the standard off of the iron brake shoe with it often referred to with the low friction shoe. The shoe that has been served with the section of 1935. Present being phased out with the introduction of the high phosphorus gas metal shoe. 1965 the air adopted with the alternative type of the brake shoe with the known with the composite composition shoe with a shoe with which also refers to the high friction shoe with the developed partially to be used with a truck mounted brake ring which become with a lower effective low ratio lever ratio required with higher friction shoe with the shoe with the required level of braking should be know that how with all the composition shoe with the not highly friction shoe with the low friction composition shoe with the use composition shoe with the manufacturer are used primarily locomotive typically have a higher brake shoe. Forza freight car summary with the brake show terminology found with the table 2.4. Show the material cast iron high phosphorus has no friction. Cast iron no high phosphorus and have no high friction. And yes, they have low friction. Composite also has low friction, high friction. 212.1. Cast iron shoe with the cast iron brake shoe with the design of the AR adopted in 1935 with the material specification. Cast iron shoe published with the AR specification M40156. Figure 220 illustrates dimension, pair numbers of different cast iron shoe thicknesses, and functional performance of the cast iron brake shoe with involved with the frictional character of the relative of the steel of the freight cars. Wheel with the friction value with the very considerable, depending on the operating condition, with the extent of the brake shoe force, particularly directly affected with the speed, with the value of the condition of the friction, and with the table 2.5, consider approximately range of the cast iron brake shoe. Train speed 0 to 7, 5, 7 to 10, and a half, 10, 20, and 50. Shows the conditions of the shoe. 212 composition shoe with composition brake shoe with developed in the early 1960s provide with the high frictional level of the level required with the truck mount brake rigging. Provide improved wheel wear with the thermal capacity characteristics. Section 5 compared with the cast iron shoe the specification high friction composition brake shoe published in the AR specification M926 or 92672. Figure 220 for the next page illustrate the dimension composition shoe and AR shoe type designations. Functional performance V with the composite brake shoe with the indicate with additional overall high friction involved with the values for the composition friction increase with the zero train speed with compared with the cast iron shoe with which have the coefficient friction with the degree of the train speed. Table 2.6 illustrate with the approximate value of the coefficient and coefficient for the friction with the composition with the high friction brake shoe with these values for the calculated for the test data. It shows 0, 15, 10, which is and then 10 through 15, 20, 25, and 30 have 0.3 coefficient friction rating. Extent of the dynamometer type of the dynamometer has been demonstrated with the increase of the wheel thermal capacity of achievable composition brake shoe with compared with the cast iron brake shoe. Section 5 results interview of the professional industrial general support with the conclusion of the research brake shoe and wheel wear also said with a greatly reduced the use of the composition brake shoe. 212.3 high phosphorus per shoe with an effort to reduce the brakes produce sparking characteristic of the cast iron shoe with a high phosphorus content. Cast metal shoes have been introduced with the alternate with a standard cast iron shoe. Frictional character for the high phosphorus shoes are approximately the same as the cast iron shoe for table 2.7 on the following page. Illustrate approximate value of the coefficient friction of the high phosphorus shoe with the value of the calculated on using the breakaway test data. Approximation value of the coefficient friction of the high phosphorus brake shoe 0.5 and 10. 10 is 0.25, 15 0.17, 20 0.15, 25 0.15, 30 0.14. Graphical comparison and friction character of the three type of the brake shoe discussed in preceding. Presented figure 230. Other functional performance characteristics compared in table 2.8. 2H show the other functional performance characteristics. High phosphorus composition brake shoe wear characteristics comparing cast iron high phosphorus improvement that report with brake shoe wear. Composition significant improvement that relate with the both shoe and wheel wear. Sparking character compared with cast iron high phosphorus greatly improved with no sparking. Almost no sparking, virtually sparkless composition. Wheel thermal capacity compared to cast iron and high phosphorus unknown. Composition improved. Brake shoes were played with the field with the remove of the spring with the brake shoe with the control of the brake shoe with the brake head, brake beam, new brake shoe with the advent position, the key with the vertically reinserted through the almost slots provided with the brake head with the back of the brake shoe with the figure 228 with the two type of brake shoe keys are shown figure 230. Alright, then show the two type of the brake shoe keys. Propose substantial greater friction level with a high friction composition brake shoe that is important with the composition shoe with not misapplied with the car design with a low friction shoe, although the car presently occurred with the physical procedure for the effect to prevent the misapplication of the brake shoe. Furthermore, rules of which will become effective in 1979 with the physically impossible to misapply with the brake shoe procedure effective the presently, even in those that will become effective in the future as shown by the table 2.9 on the following page. Chapter 3, we'll go and look at this real quick, and then we'll cut the tape. So this shows that some of the rules designed to prevent misapplication of brake shoe, brake beam, new installation, description, brake beam had E84B with reject lugs and high friction composition brake shoe. Your freight cars, effective new and rebuilt cars modified with a composition shoe. Today is presently official manual of the interchange rule 88B, D, and B and D. Brake beam renewal. The description rule: brake beams renewed with a composition brake shoe that must be renewed with a brake head with a reject cast iron shoes, all equipped with a composition shoe for the cars affected presently. Fuel manner interchange rule 6B. Brake shoes renewal: all high friction composition brake shoe for the U that must have the rejection lugs. Prevent their installation on the brake beam with equipped with a cast iron brake shoe. All cars January 1st, 1977. Official manual interchange rules 88D. And then brake shoes manufacture all high friction brake shoes, which manufactured with the rejection lugs will reject the brake beam equipped with the cast iron brake shoes not applicable. Cars effective January 1st, 1977. The manual standard recommended specifications G92 672. Chapter 3. Chapter 3. Operation Performance Design Freight Car Air Brake Systems.